Okay, well, Tim, thank you for joining us for this interview.
My pleasure.
Tim Mattson is Principal Engineer at Intel Corporation, and I was just given a day-long tutorial on OpenMP in the OpenMPCon. Let me start. During the tutorial you mentioned the new memory architectures being developed by Intel, and how do you see OpenMP handling the new features in the...
I don't know, but I assure you we're working hard on it. Yeah, I mean this is an extremely interesting time in the world of hardware. When you look at the state of DRAM and how it's packaged with CPUs. So Intel has the next release of its Xeon Phi processor family, codenamed Knight's Landing. And we've already said there's going to be some memory just right there in the package, some DRAM. We call it MCDRAM, which I think stands for multi-channel DRAM. So you've got this DRAM right on the package, which has very, very high bandwidths, as another level of memory hierarchy. And you can configure it as a cache, you can configure it as an extension of the other DRAM, you can configure it as a separate scratch pad. There's different ways to configure it. So that just greatly adds to the complexity of the memory hierarchy. Then on top of that, we have non-volatile memory. So non-volatile memory in a server platform it's potentially a game changer. I'm not sure how it's going to be used in the HPC space, but in the big data space where I spend a lot of my time, it's going to have huge impact as we re-implement databases, taking in fact that you have this non-volatile memory. If a node goes down, you no longer lose all the memory. So this is yet another layer of the memory hierarchy that will be existing in the off-the-shelf server boards that we build HPC systems from. So how is OpenMP going to deal with it? I don't know. We're working on it very hard. But I don't know how it's going to deal with it. But it's going to have to. And I look at some of the latest features with affinity and places and nested parallelism. I think these are going to play a very big deal, a very big role. We're going to have to. We've kind of ignored before that you have to deal with the fact that you have a hierarchy of threads where different layers in the threads have a different relationship to levels in the memory subsystem. I think that's going to become even more important.
You also mentioned that you're involved with the big data space.
Yes.
So do you see OpenMP making inroads in that application field?
Absolutely not. It's a different world. There's no reason it couldn't. And I talk to people about this all the time. There's just different communities seem to have their tastes for different programming models and different approaches. The big data world's in love with Java. We don't even have a binding of OpenMP to Java. I wish we did. I've been saying for years we should, but we don't.
So that would be one way to get into that field. Then it would be
maybe. The other thing is the different styles of parallelism. They tend to work at much higher level of abstractions, and so I don't know if OpenMP is really a good fit for that community. I mean, technically looking at what OpenMP does, look, it's a general multi-threaded programming model, and with the target and device constructs, it handles accelerators. There's absolutely no reason it couldn't play a role in that space. But there is an idea of fashion and what people are what people are used to, what sort of things they like in programming, and OpenMP just really hasn't made big inroads outside HPC.
And what are the main applications field where OpenMP is most relevant to your knowledge and impression and your experience?
Well, I'm a scientific programmer. So in the world of high-performance computing and supercomputing, MPI plus OpenMP is the standard model. So, I personally have done a lot of work in molecular biology, and OpenMP is all over that space. Molecular dynamics, quantum chemistry codes, basically anywhere you see a differential equation you want to solve, OpenMP is great. So, OpenMP has had excellent penetration in the HPC space. And what I am very excited about is the ability to program accelerators and GPUs with OpenMP. My obsession, which will be clear every time you hear me give a talk this week at OpenMPCon, my obsession is I want a single software base that can move between the CPU, the GPU, and now FPGAs. I want one software base to cover all of those.
And the embedded systems.
And potentially embedded systems. Sure. Today there's only one way to do that. It's called OpenCL. And OpenCL works for that, but for whatever reason, remember what I said about fashions and different programming model communities latch on to different things. The HPC community has not particularly been thrilled about adopting OpenCL. I think that's a mistake, but it doesn't matter what I think, right? It's what does the programming community adopt, all right? Programming communities looked at OpenCL and said, no, thank you. But there's a lot of interest around directive-based approaches in the HPC community. So I think with OpenMP 4.0 and 4.1 and the target and device directives, we have a shot at creating that software foundation that will work across GPU, CPU, embedded, and FPGA. We're not there yet, though, because it still is today. OpenCL is the only way we can do that. But I'm very, very hopeful. The ball is in OpenMP's court. If the OpenMP community, meaning the vendors and the architecture review board, get their act together and get a standard out there and deployed, we have a chance of taking over that platform for OpenMP. So I'm very, very excited, and I'm just chomping at the bit to be able to take a GPU and program it from OpenMP.
Well, let's look forward to that then, and thank you very much for your time.
Oh, sure.
Okay,
Thank you.
Good.